How do computers make decisions? In honor of Computer Science Week, we're going to try and answer that question. And how would a computer using a camera figure out the difference between this chihuahua and this muffin over here? Modern computers can accomplish incredible things. They can play chess, drive cars, diagnose diseases, but whatever the application, it all breaks down to, can the computer ask the right small question and can it get the right answer back? So decision trees, these yes or no questions, are fundamental for computers and understanding. We're going to end up playing this game where we get to select some sort of random character, and we're going to watch that decision tree in action, and it will guess the character. It's incredible, and let's get into it. So, what is computing? How do we start here? So computing is simply having some sort of starting stage, and then some magical stuff happens, and then we get some sort of output. It's the act of taking an input, processing it, and producing an output. So for example, this mouse, when I click it, that's an input, and then on the screen, you'll see that something happens. That's the output. How does it happen? The steps in between me clicking and you seeing me moving this, what exactly is happening behind the scenes? Well, the computer is making a lot of decisions using yes or no decision trees. In facial recognition, for example, a computer may get a camera as an input, perform some sort of thing, and then produce some sort of description as an output over here. So we can see the subject is obviously a chihuahua and a turtleneck over here, not a muffin. So our first example breaks down the process of facial recognition into a sequence of simple decision steps. A decision tree is yes or no questions that help the computer decide what to output, like what is the thing. Okay, so we see this decision tree over here. Just like reading a flowchart, the computer starts at the top over here and then answers each question based on its input until it gets to the bottom, the output over here. So with this decision tree, what's the first question the computer will ask of any face? According to this one, does it have a beard? Yes or no? So that would be the first question that it's going to ask. Here's how the computer steps through the decision tree when the input face has no beard, has long white hair, and no glasses, and is not smiling. So first it says, okay, does it have a beard? No. Let's move on to the next step. Okay. Does it have brown hair? No. Okay, let's move on to the next step. Smiling? No. Move on to the next step. And then there's no more questions, so it thinks that this is going to be the output, regardless of if it actually is. It must be the one on the right over there. So, well, let's play it and watch it happen. Beard, brown hair. Yep. All right. So it thinks that that's going to be the one over here. It concludes the face would be the second face from the left over there. It's just going to go through its steps. So what would the computer output if presented with a smiling face with short blonde hair, no beard, and no glasses over here? We can go through them and we can try and figure that out over here. So smiling face, short blonde hair, no beard, no glasses. So starting with beard. Beard is no beard, so we would move on to the next one over here. So we go on to the next. Then we have brown hair. Short blonde hair, that's not brown hair, so we move on to the next step over here. Smiling face, yes, smiling, so check that. So we go down over here. Then blue hair, it says short blonde hair, so not blue hair, so we can move on to the next one. Short hair, not long hair, so move on to the next one over here. Then it says over here black hair, nope, short blonde hair, keep moving on. Which is going to be beyond that. So if it's not black hair, it thinks it's this person. So we're going to check it, and that ends up being the one. Whether or not it actually matches the description, it depends on the quality of the questions that we end up asking over here. So we can see over here that this is essentially what I just walked through, and this is what the computer is going through. It's saying no, no, it's going through, and it's just simply going through the decision tree, and that's how it gets to that black hair example over there. Now that you've seen the face recognition decision tree and work, it's time to try building one from scratch. So it's going to go through and it's going to make us ask some questions. Imagine you want to make a decision tree that can distinguish in these four faces. So if we want to know the root of the decision tree to split it into two groups, we have beard, no beard, robot, blonde hair. So which question should we ask the two in order to best split it into two ones? Do they both have black hair? Well, two have black hair, two don't. That's a possibility. Is the mouth open? Open, 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 closed. So that would be 3 and 1. Are they wearing glasses? Only one is wearing glasses. None of these will work. Well, black hair would split it into two groups, so that one makes sense as a question to ask. So the computers are going to, a programmer, like the human's going to have to think of what questions are best to ask. So using this black hair, we then would be able to then try and ask another question to narrow it down and try and figure out what the part of that group is. So what single question could you ask both of the groups to narrow it down to a single face? Do they have a beard? Beard, beard. Well, that question doesn't help this one. Are they wearing a hat? Only one of them is wearing a hat, so it wouldn't help for this group. Are they wearing glasses? It helps this one. None of these are going to end up working over here. So we're not going to be able to use those questions to accurately get that question over here. No single feature can distinguish both faces of groups. However, you can make a decision tree that distinguishes all 4 faces by asking a different follow-up question based on the answer to the first. So those follow-up questions are really going to be helpful. And in the game that we're going to play, getting these follow-up questions right is going to determine if we, in fact, get the right decision. So we can see over here the ability to ask different questions makes decision trees quite powerful. So they made glasses and beard, so those follow-up questions help you determine which person is going to be that one. So which face will the computer land on if you use to identify this blonde-haired face over here? So brown hair, that's a no. So we would go over to this category over here because it's not brown hair. Then black hair, not black hair. So move on to not black hair, and it thinks that this is the woman, but it obviously is not. The questions, we didn't have the right follow-up questions in this case. So making sure you get those follow-up questions, they're different as can be, but the computer decided they're similar. So, a computer using a camera can decide that things that are in fact similar are, the same, even though they may not be. And this implication is actually very important, especially when we get things like Teslas and self-driving cars, and these computers are making decisions based off of these decision trees. They don't see the faces or dogs, they just consider the features we instruct them to focus on over here. And if we pay attention, we'll see real-world examples of this kind of failure, and cars can lead to accidents and, this type of stuff. So that's basically how these computers are working. They're using these, decision trees to think. Now that you know how it works, it's time to play Akinator, and it's trying to see if you can make the computer guess the character correctly. I also have a video example on the next slide that you guys can go through, and you can watch me guess the character. All right. See you. Have a good one.